So, in this video, we will be discussing the difference between blocking and non-blocking assignment. And I will be simulating some examples to explain that why blocking is more suitable for combinational logic, whereas the non-blocking is more suitable for the sequential logic. So let's begin. So here is the example of an expression with the blocking assignment. So in a blocking assignment, the evaluation and the assignment is done immediately and it is done in the active region. And as for non-blocking assignment, the evaluation of the RHS is done in the active region, and right after that, in the very same time slot, in the non-blocking region, the assignment is done. So let's understand this timing region with the help of a diagram. So here is a somewhat simplified Verilog timing region diagram, and in a given time slot, these are all the regions which executes one by one. So for the blocking assignment, the evaluation and the assignment is done immediately in the active region. It doesn't wait for another region. Whereas in the case of non-blocking assignment, the evaluation of the RHS is done in this region, the active region, and the assignment is done here in the non-blocking assignment region. So that's why it waits for the next region to get the assignment to be updated. So coming back to QuestaSim, let's write an example code to understand this better. So for the first example, we will be writing a code for this combinational circuit. Here you can see that there are three inputs, and the first two inputs, that are A and B, are passed to an AND gate. Then their output is assigned to X and to a OR gate, where we also pass another input, that is C. So after that, their output is assigned to Y. So let's begin with QuestaSim. So here on QuestaSim, I will begin with writing the code. I will have three input signals of 1 bit each. And two output signals. And I will be using always comb to show that we are building a combinational logic. So as per that combinational logic, we have an output X, which is assigned to the AND operation between the input A and B. And there is another output Y, and it is assigned to the OR operation between X and C. And one more thing, I should have mentioned the port list right here. So I will do it. Now the code is complete. So now we will write a test module to simulate this code. I will instantiate the module. I will provide some input to both A and B and even C. I will concatenate them. Let's give it 1 1 0. So I'm giving 1 to A and 1 to B and 0 to C. Let's use $stop. I will be displaying the value of X and Y. So let's run the code. First I will compile this. Okay, there are no errors. So let's run this code. Okay, I was supposed to write $tab. Oh, got it. So as you can see, the output is correct, and it is obvious because you will see we are doing here the AND operation between A and B. And what are the values of A and B? Those are 1 and 1. So it's 1 and 1, which is equals to 1. So that's why X gets the value of 1. And when it gets the value, after that only the operation happens here. So the Y receives the updated value of X from the previous expression. So the value of X is 1 and the value of C is 0. So what is 1 or 0? It is 1. So that's why y gets 1. So yeah, the output is correct. So what happens if we replace the blocking assignment right here with non-blocking assignment? So firstly, it is not recommended, or you should not use non-blocking assignment inside the always com block. It is meant to be used with the always ff block uh, because always ff is meant to be used for sequential logic, and always com is meant to be used for combination logic. And non-blocking assignments are more suitable for sequential logic. So here, what happens if I does this modification? I'm not changing anything in the module test, and I will go ahead and run the simulation. Well, I forgot to save my file. I will save it and I will run it again. So here you can observe that we are getting x is equals to 1, which was same for the blocking assignment. But here you can see that we are getting y is equals to x, and x is basically undefined. So let's go through the code and let's understand that what is happening right here. So here you can see that the first expression is x assigned with a and b. But here you will see that we are using non-blocking assignment. So what happens here is that the evaluation of RHS is done in the active region. On the same time, the evaluation of RHS here is done in the active region. So the assignment of RHS to LHS is deferred until the NBA region. So that's why the following expression doesn't get the updated value of x, and it gets the default value of x. So what is the default value of x? Since s x is of logic type, the default value is undefined, which is x right here. And if you will do the OR of x with 0 or anything with 0, it will be the result itself. I mean, it will be x in this case. So that's why we are getting x. So here you can understand the parallel or the sequential behavior of non-blocking assignment. The following expression doesn't get the updated value of x, and it is mutually exclusive in some sense. And unlike this, in the previous example in which we were using the blocking assignment, the second expression will always get the updated value of x. So let's move on with other example, and this will be a very simple one. First I will quit the simulation. I will declare two logic variables that are A and B. So it is going to be a very simple module. In this module, we will be swapping the values between A and B. So let's begin. So first of all, I will give some values to A and B. Let's give 0 to A and 1 to B. After that, I will be swapping the value using non-blocking assignment. Then using $stop, I will display the value and check whether the values have been swapped or not. Okay, let's run the simulation. Okay, so as you can see here, the values have been swapped. So the initial value of A was 0 and the initial value of B was 1. And right here in our results, we can see that A gets 1, which was the initial value of B, and similarly B gets 0, which was the initial value of A. So what happens if we replace the non-blocking assignment here with the blocking ones? Let's save the code and run it again. So as you can see that we are getting 1 for both A and B, which is undesired for this case. So what is happening right here is that A is getting updated with the value of B, which is 1, and B is getting the value of the updated A. So this expression evaluates after this one. So here, since it's a blocking assignment, the evaluation of the right side and the assignment is done immediately. And after that only the assignment and evaluation is done here. Because of this reason, we are unable to swap the value. But if we instead use the non-blocking assignment, the evaluation is exclusive and the assignment is deferred till NBA region. So for that particular reason, B is getting the previous value of A and A is getting the previous value or the initialized value of B. If we have used the non-blocking assignment here, both these statements were exclusive or mutually exclusive to each other, which gives a sequential logic. So that were the differences between a non-blocking assignment and a blocking assignment. I hope you find this video useful and stay tuned for more. Thank you so much.